So the question we have is integration of ln in bracket under root 1 minus x plus under root 1 plus x dot dx minus x dot ln x in bracket 1 minus x in root plus 1 plus x in root. So to solve this question, I have to integrate it and then I have to subtract this part from it. So to integrate, I will take 1 dot ln root 1 minus x plus 1 plus x dx. I will take this in form of pi part, that is from using I, L, A, T, E. So the first function will be this and my second function will be this, minus x ln root x 1 minus x plus root 1 plus x. So applying pi parts is u dot v dx equals to, if this is first and this is second, writing first and second's integration means u integration of v dv minus du upon dx dot integration of v dx here into dx. So this is by parts. So my first function was ln, so I will be writing ln under root 1 minus x plus under root 1 plus x dot integration of 1 dot dx is x minus integration of x 1 dot dx dot differentiation of this part, that is d of ln root 1 minus x plus root 1 plus x upon dx and its whole's integration. So this is I have to calculate. I haven't written this part, so first let's integrate this part, then we will subtracting this part from here. So this will become x dot ln 1 minus x plus 1 plus x. If I see this part and this part, both are same, x dot ln under root 1 minus x plus under root 1 plus x. So these both will be get cancelled here. So the answer of this question will only be integration of this part. So we just need to calculate this. So minus integration of x dot differentiation of this is 1 upon under root 1 minus x plus under root 1 plus x. So this is the differentiation of ln x. Now I will differentiating this and this. So differentiation of this part is minus 1 upon 2 under root 1 minus x, and this part is 1 upon 2 under root 1 plus x. As if I take this is 1 upon 2 and minus 1, so it will be 1 upon 2 and the power will come outside, it is 1 upon 2. So from here it is 1 upon 2 and from power minus 1 upon 2 it will be become 1 upon under root 1 minus x. So this is the part we need to integrate dx. So first of all I will just simplify it so it will be easier to then integrate x upon under root 1 minus x plus under root 1 plus x, and I will take this 2 that is common as outside, minus 1 upon 2 here, and I just have to multiply it is minus 1 plus x under root 1 minus x upon under root 1 minus x square dx. So now minus 1 upon 2 x upon, if I, sorry, this will be add, if I take this and this, it will be Even face one cell. That if I see this value and this value, what I'm saying is under root 1 minus x minus under root 1 plus x upon under root 1 minus x plus under root 1 plus x and under root 1 minus x square dx. So I'm going to rationalize this part. So minus 1 upon 2 integration of x upon under root 1 minus x square. After rationalizing it, this will become its whole square, that is 1 minus x under root minus 1 upon 1 plus x its square upon is under root 1 minus x square minus under root 1 plus x square dx minus 1 upon 2 integration x upon under root 1 minus x square. So it will give 1 minus x and plus 1 plus x minus 2 under root 1 minus x square upon 1 minus x, then minus 1 minus x. Plus 1 plus dx minus 1 upon 2 integration x upon under root 1 minus x square. So from here x and x both are cancelled. 2 1 plus 1 2 minus 2 under root 1 minus x square upon 1 and 1 get cancelled minus 2x dx. So from here x and x get cancelled. From here 2 and 2 get cancelled. So I am left with minus 1 upon 2 integration 1 minus under root 1 minus x square upon under root 1 minus x square, and this minus will get positive dx. So if I separate both apart, integration 1 upon under root 1 minus x square dx minus 1 upon 2 integration 1 dot dx. So integration of 1 upon under root 1 minus x square is sine inverse. So it will be under root a square minus x square 1 upon 2 sine inverse x, okay, minus 1 upon 2 x plus c. So this is the answer of this question.